Given question, mechanical injector has nozzle orifice diameter is equal to 0.948 millimeter. Maximum cross-sectional area of the passage between the needle cone and the seat is equal to 1.75 millimeter square. Coefficient of discharge for orifice 0.85. Coefficient of discharge for the passage 0.80. Injection pressure 175 bar. Average pressure of charge during injection is 25 bar. When the needle cone is fully lifted up, calculate the volume rate of flow per second of the fuel through the injector and the velocity of jet at that instant. Density of fuel is equal to 850 kg per meter cube. Let us understand given data. This is the closed type injector and the data is given at the injector inlet as well as at the fuel metering orifice. At the fuel metering orifice, we will use the suffix F. Nozzle orifice diameter is given. So we will use here the suffix F. So notation we will give as a dF for the diameter. So dF is equal to 0.948 millimeter. But the standard unit is meter. So we will convert this into meter. 0.948 into 10 raised to minus 3 meter. Cross-sectional area of passage between needle cone and seat. So this is the data at the inlet of the injector. So this is the cross-sectional area. So we will use here the notation A and it is 1.75 millimeter square, but the standard unit is meter square. So we will convert this into 1.75 into 10 raised to minus 6 meter square. Then coefficient of discharge of orifice. So at orifice we will use the suffix F. So coefficient of discharge, that is CD, to the suffix F, that is CDF, is 0.85. Then the coefficient of discharge of the passage. So what is this passage? So this is the passage between needle cone and seat. So this is the information at the injector inlet. So we will use here the notation CD and it is 0.80. Now injection pressure is 175 bar. So injection pressure, that is P injection, PINJ. It is 175 bar. So this bar, the pressure is given in bar, but we know that the standard unit is Newton per meter square. So which is equal to 175 into 10 raised to 5 Newton per meter square. Charge pressure. So this charge pressure, that is P charge, it is 25 bar. So again we will convert it into Newton per meter square, that is 25 into 10 raised to 5 Newton per meter square. Density of fuel. So this density notation is rho and density of fuel, that is rho F. It is 850 kilogram per meter cube. So this is the given data and from this given data we have to find out volume rate of flow per second of fuel. So volume rate of flow of fuel we have to find out, as well as velocity of fuel jet. So it's a notation for volume we will use V dot F. So I will write here V dot F, that we have to find out, and velocity, that is Vf. So because of fuel we will use here the suffix F. Now why we have used here V dot and why here Vf? Now we know that the unit of the velocity. So velocity unit is meter per second. Now when we multiply with area to this Vf, then area means we have to multiply with meter square. So when we multiply here with meter square, then it will become meter cube per second. So this meter cube per second is nothing but volume rate of flow. So we have to find out volume rate of flow in meter cube per second and velocity of fuel jet in meter per second. So when we multiply Vf with area A, then we will get here V dot F. So here is the notation V dot F and Vf. Now why to multiply here area with Vf? Because we have formula for this mechanical injection system in terms of Vf. So what is this formula? Vf is equal to, that is the velocity of fuel jet, is equal to CD, that is the coefficient of discharge, under root of 2 inside the bracket P injection minus P cylinder divided by rho F. Now if we observe, P cylinder is not mentioned in the question. So P injection, that is, this is the injection pressure at the injector inlet, and P charge, that is the pressure at the fuel orifice, is two types of pressures are mentioned. Now we will convert this formula Vf in terms of V dot F. So we have to multiply here on both sides with area A. So when I multiply with area A, then Vf will become V dot F, and here CDA. So CDA under root of 2 P injection minus P cylinder divided by rho F. But this P injection, that is the pressure, is mentioned in bar. So we have to, when we put this value P injection 175, then we have to multiply here with 10 raised to 5. So we will multiply here with 10 raised to 5. So this P cylinder we will consider also in bar. So here, how to simplify this? We have to remove this square root. So I will square on both sides. So when we square on both sides, then it will become V dot F square is equal to CDA bracket square, then 2 P injection minus P cylinder into 10 raised to 5 divided by rho F. So this square root is getting removed. Now there are two types. First type is at the inlet of injector, and second type is at the fuel orifice. So at the inlet of injector or at injector inlet, this CD is given. Then area A is also given. So we have to put that value. And this P injection minus P cylinder we will keep on one side and all the data to the other side. So I will transfer all this term to the other side. So what is the equation? So P injection minus P cylinder is equal to V dot F square into rho F divided by CDA bracket square into 2 into 10 raised to 5. So this is the equation. Now at injector inlet, CD is equal to CD only, area A is equal to A only, and V dot F and rho F. So rho F is also mentioned in the question. P injector is given 175. So this P injector minus P cylinder we have to take in the bar, because we have multiplied already here with 10 raised to 5. So we will put the values. So when we put the values, then we will get the answer 175 minus P cylinder is equal to V dot F square into 192.3 into 10 raised to 7. So this is the equation number 1. Now we will move to the fuel orifice. Now at the fuel orifice, how this equation will become? So again we have to take P cylinder minus P charge, because here this cylinder pressure, that is the combustion pressure, is higher than this charge pressure. So here we have to take P cylinder minus P charge is equal to. So on left hand side it will become P cylinder minus P charge is equal to. On the right hand side, which are the changes? So V dot F square as it is, rho F as it is. Now instead of CD, because the coefficient of discharge at the orifice is CDF, so we have to write here CDF, and area at the fuel orifice is known as AF. So how to calculate this AF? Because the diameter, orifice diameter DF is given. So we know that it is equal to pi by 4 dF square. So pi by 4 dF square we have to write. and here whole bracket square into 2 into 10 raised to 5. So we have to solve this and we will get the equation P cylinder minus 25 is equal to 1349.2 into 10 raised to 7 into V dot F square. So this is the equation number 2. Now if we observe equation number 1 and equation number 2, then there is two unknown term. So this is V dot F square, this is the common unknown term, and here is P cylinder. So here is minus P cylinder and here is plus P cylinder. So if we add this equation number 1 and 2, then on left hand side this minus P cylinder and this plus P cylinder is getting cancelled, and we get only equation in terms of V dot F square, and we can easily find out this V dot F. We will add the equation number 1 and equation number 2. So on the left hand side it will become 175 minus P cylinder plus P cylinder minus 25. So this P cylinder and P cylinder is getting cancelled, and it is 175 minus 25 is equal to, now on the right hand side when we add these two equations, then V dot F square and this 10 raised to 7 is common term. So we will take outside the bracket. So V dot F square inside the bracket 192.3 plus 1349.2, bracket complete, into 10 raised to 7. Now we have to find out this V dot F square. So we will transfer this term to the denominator. So it will become 150 divided by, so when we solve this, 1541.5 into 10 raised to 7. So we will take square root on both the sides. So V dot F is equal to 9.86 into 10 raised to minus 5, and unit is meter cube per second. So this is the standard unit. Now to find out the velocity of fuel jet, that is Vf, we have to first find out value of this P cylinder. So how to find out? So we will put this V dot F in the equation number 1. So we can put this value either in equation 1 or in equation 2. So we will select this equation number 1. So there is only one unknown term, P cylinder, and it is 156.30 bar. So if we observe, we have assumed that the P cylinder is in bar. So in earlier when we take the equation for V dot F, then P cylinder is in bar. So here when we calculate this value P cylinder, then it is in bar. Now we have to find out velocity of the fuel jet. So we have to consider all the notations at the fuel metering orifice. So which are these notations? So it is the coefficient of discharge CDF we have to consider. So Vf is equal to, we have formula Vf is equal to CDF inside the bracket 2 P cylinder minus P charge divided by rho F. So we have to take at the orifice, that is P cylinder minus P charge. So at the orifice these notations we have to take. So we will put the value. So P cylinder, it is in bar 156.3, and P charge, so pressure of charge is also given, that is 25 bar. So we know that the standard unit is Newton per meter square. So outside the bracket we will multiply with 10 raised to 5 divided by rho F, it is density of fuel 850 kilogram per meter cube. So when we solve this, then we will get the answer, velocity is 149.4 meter per second.